Okay, guys, hopefully you can hear me okay. My headset apparently didn't want to connect after break. I think it still wants to be on break. Um, but we're going to get started on complex numbers. You guys should be somewhat familiar with the idea of complex numbers. It's the idea of if you take the square root of a negative, normally this isn't possible. So what we do is we know that the square root of 4 is 2. So the real question is, what do we do with the square root of negative 1? And I'm apologizing for how the board's acting right now. Let me see if I can by unplugging and plugging it back in. Um, so if the square, we can split this up into the idea of it's the square root of negative 1 times the square root of 4, which we can then call the square root of negative 1 times the square root of 4. So we know the square root of 4 is 2. So what we do is, since we don't really know what to do with this square root of 1, it's an imaginary number. Nothing times something else can give you that. So we're going to call it I. So this is where the i's come into play. And the thing about I is equal to the square root of negative 1, like we said. But if we square I, this means we have the square root of negative 1 times the square root of negative 1, which means it's negative 1. And if we cube I, we're doing negative 1 times cube. We're doing negative 1 times an I, because I squared, we already said, was negative 1. So that means that, in other words, I cubed is just negative I. I'm sure Edmentum's going to end up doing this again, but this is just a review. So if I squared, or I to the fourth would be I squared times I squared. So if that's the case, that means we have negative 1 times negative 1, which means I to the 4 is just 1. So anything times I to the 4 is itself. So if we have something like I to the 5th, we'll notice that the cycle starts all over again, because this is I to the 4 times I. So these are our only possibilities, is I, negative 1, negative I, and 1. And this makes it interesting because that means that even numbers, um, even powers are an actual number, whereas odd powers are this imaginary number. And I'm sure, like I said, we're probably going to get into that today. Or in our next video, since this is 50 slides, I am probably going to make this a 3-parter. We'll see. All right, so complex numbers. So our objective in this lesson, we want to define and work with complex numbers, which I probably already did most of. So make sure to watch the introduction. As I said before, I'm not going to watch these videos um, with you, because that seems kind of pointless. But this one thing I do like to cover from this video is that a complex number, it has a real component and an imaginary component. And the imaginary component is just anything with that I. So imaginary numbers, they've proven in the um, they've proven in math later on that imaginary numbers aren't necessarily imaginary, but the name kind of just stuck. So that's what we use it for. So what we're going to keep doing here, so study of complex numbers, you guys can read this to get more on the history of it. But the main thing we use imaginary numbers for, as I mentioned before, is when we're dealing with the square root of a negative number. So here we see that we have no definition for this. So here, like I did with our square root of negative 4, they're splitting it up. That way we can put an I. So basically, whenever you see a square root, something you can square root but has a negative, you just put a little I. Put I in front of it. If you're dealing with something that doesn't have a perfect root, you can split it. I like doing the factor tree personally when I'm doing these. Cross them out after you split them. If we're doing the square root of 12, we have a pair of 2's, so this couple gets to come outside. And we cross out everything that we did factor, and this 3 that's by itself stays inside. So that was something I always said. The couples go outside of the square root, and the single stays inside. And since this is a negative 12, we're going to put the I right in front, or right to the right of our leading coefficient. In this case, that's the 2, because the 2 is outside. If we couldn't bring anything outside, it would just be I and the square root of whatever we're dealing with. But since we could bring something outside, it's going to go to the right of that number. All right, so moving on here. All right, so we're going to solve this problem right here. So obviously, we have to get rid of that negative. So what we do, in order to get rid of that negative, we just take out an I. And our real question is, what is the square root of 79? Some of you might have the perfect squares memorized, but 79, the square root of 79 is 7. So we're going to call this 7I. That's all we're doing here. Nice and simple start. Get you guys used to being back from break. All right, so this next one. Well, now this is a little more complicated. So we can take out the I, the negative, by changing it to I. Now we have 28. So I factor tree this. I'm going to factor tree it into 4 and 7. And that's 2 and 2. So this factors into 2I. And because we have a group of 2's, we're obviously going to cross out the 4 and the 28. I just did it. I'm sorry. And we're going to take the square root of 7, since 7 did not have a couple to go with. Perfect. All right. One of the few times that Edmentum and I get along. All right. So this one, we have an outside number. So the first thing we're going to do is we need to take out that negative. So it's negative 2I. So the negative 2 stays the same. We're just doing taking the I to get rid of the negative inside the root. It does not affect this negative. All right. So when I'm looking at this one, I want to say it's 15. But anyways, I don't know what it is. I know it ends in a 5, so I'm just going to factor out a 5, and I get 125. So I'm going to take out a 5 again. And then this is going to give me 25. And then I see that there's a 5 and a 5. So I notice that I have a 5, 2 pairs of 5s here. So in other words, 25 times 25 is 625. But I have 2 pairs of 5s, so I have to take out those 5s. Nothing's inside the square root, so I don't really bother with that. But I do have this negative 2i that I dealt with before. So this turns into negative 2i times 25, which makes this negative 50i. So sorry if I went a little too fast there, but the main idea here is do your factor tree, find your pairs. If there's 2 pairs, multiply those 2 together, and then multiply by anything that could have been outside before. So this one's kind of teaching us that I doesn't change with the negative. It also teaches us that you have to multiply if there's more than one pair, those numbers have to get multiplied together, and you also have to multiply by the leading coefficient if there's one already there. So we're just going to say this is negative 50i. All right, so this tutorial doesn't look that bad so far. It looks like it's just been a bunch of practice problems. So let's deal with something like this. This is a quadratic formula. So in case you guys don't remember the quadratic formula, it's negative b plus or minus square root of b squared minus 4ac. The only difference here is it looks like they've all over 2a. Is it looks like they've already simplified this, and it brought out a 2. And they didn't simplify it all the way because of that negative 100. So we're going to deal with what happens with that negative 100. Shouldn't be too bad. So first things first, bring down the -5 plus 2. We're going to put a little I here, square root of 100. Well, the square root of 100 is 10. So this ends up being -5 plus 20i, because this is going to be our 10. 10 times 2, all over 10. So what this ends up being is we can split this up because of this positive sign on top into -5 over 10 plus 20i over 10. And this will reduce to -1/2. Go down here a little bit more. -1/2 plus 2i. And we can do that pretty simple. So go back to my mouse mode right now. So I'm going to do negative. Going to hit this little fraction button. Where'd it go? There it is. 1 over 2 plus 2i. That's perfect. So we're going to do that. Nice and easy. All right, moving on to the next one. Complex numbers. All right, so we have these complex numbers. So basically, if it has an I, even if it's bi, meaning any number and I, it's just imaginary. A is going to be a real part. So we've kind of talked about this before. This one, obviously, it's 0 or just A. So I think they're just going over general case scenarios. Edmentum's kind of funny, where sometimes it expects you to know all these complicated stuff. Sometimes it's like, we're going to explain every little thing for you. So let's go into this next one. All right. So in this problem, combine the real and imaginary components and write the complex in standard form. This 15 is the real, and 5i is the imaginary. So all we're going to do here is 15 plus 5i. And that's all we have to do. So just remember that our real number always leads, and then our bi is going to be the next part. All right, so again, we're going to do this for the real part and imaginary part. These should be pretty easy, I hope. So we're going to write 2/3 is our real part, and then minus 3i is our imaginary. So we write the imaginary part second. Get this done. Combine the real and imaginary parts in standard form. Oh, 2/9. Oh my gosh. I don't know where I got the 3 from. There we go. Or I guess I got the 3 from here. I kind of combined them in my head. All right. That was weird. I was like, why is that wrong? All right, going to this next one. We're doing the same thing, real and imaginary part. I don't know why they have us practicing these. But let's go here. 54. Oh, let me do my little fraction button. If anything, I guess it's practice using these command keys. Fraction. And we're going to do I. Oops. Sorry. Plus I. And then we're going to do the square root of 81. Well, we can take the square root of 81. This has been the only math they've given us so far. The square root of 81 is 9. So we're going to do plus 9i. Perfect. All right, so moving on to the next one. Let's see what we have here. All right, so 17. Yes. So we're going to combine this real part and imaginary part. This one doesn't look like we have much work to it, just -16 minus I. I'm going to find the I on my keyboard there for a second. Square root of 7 should be our answer. And that's all we have to do. I don't like how they're like, oh, plus. They're doing this because of the A plus BI. So you can do it that way if it helps. Go to, oops, next one. All right, so now we're going to be talking about what happens if we need to add imaginary numbers? So you can add imaginary numbers together, you can subtract them exactly the same. The only difference is when we're dealing with exponents. Exponents, that's where I talk about that color wheel. So that color wheel is the idea of um, we need a color wheel chart, a number chart. So that number chart is this idea that everything circles around. And the easiest way to think about it, since everything circles around after 4, so for example, I1 and I5 are equal, and that's also going to be equal to I9. What you want to do is you're going to divide it by 4. So let's pretend we're doing this with 9. And whatever your remainder is, that's going to be one of the original 4. So remember, the original 4 was I to the 1, I squared, I to the 3, and I to the 4. Sometimes they don't really call it I to the 4. They call it um, I to the 0, because ironically anything to 0 power is 1, and so does 4. So it's this idea of a remainder. So a lot of people don't call it I4, they call it I0, because guess what? If this was an 8, our remainder would be 0. But anyways, that's, I think, is the most complicated part when we're doing this. And just remember that i's cannot be multiplied together. It just causes different issues um, when they're inside the square root. The main reason here is because of the fact that multiplying these, you don't know if the I squared is going to do anything. So as long as they're positive, you should be fine. But you don't want to mess with imaginary numbers with double negatives, because you don't know if something's going to cancel out that shouldn't. All right, so adding and subtracting, again, it's kind of like how we did with variables when we learned about how to do variables. The only difference is it's an I instead of an X. Pretty much the only difference here. So if you know how to do it from algebra, you should have no problem here. All right, so let's get into this. So we're dealing with complex numbers. So when you're dealing with this, you're just finding like terms. As I said, you're just working how you normally would with variables. The only difference is this I is a variable for square root of -1. It's one of those things where it looks like it's a variable. It's still considered a constant, but it's still basically a variable because it is a placeholder for something else. It's just we know what that something else is. All right, so let's take a look at this one. So in this case, this 9 is going to combine with this 12. So 9 plus 12 is going to give us, well, let me use my keyboard so I can actually write it in. 9 plus 12 is 21. And then we have this negative square root of 4 and this negative square root of 9. Now, I don't know why they did this, because we've already learned how to do square roots, but basically it's saying negative 2i. This negative square root of -4 is negative 2i. This negative square root of -9 is essentially negative 3i. So in other words, we're going to get negative 5i when we combine this together. So we get negative 5i. I don't know why they didn't leave it in. Ooh, sorry guys. Imaginary form, but that's just the case here. All right, so now we're going to do it this way. So that's an 8 and a minus. Pay attention here, there's a minus. That means we're going to swap the symbols inside. So even though this is a -1, when we distribute that, it becomes a positive 1. So we have 8 plus 1. And then when we distribute this, we get negative 4i. So this is going to be plus 6 minus 4i, which gives us 9 plus 2i. So we add our real numbers together, and then we add our imaginary numbers. Perfect. There. All right, going to the next one. So if we look at this next one, we have 0. So basically, adding 0 or subtracting 0 doesn't do anything to these. So our answer is pretty simple here. Just 2i plus 10. Since subtracting or adding 0 will not do anything to this original expression right here. Incorrect. What's going on here? Ah, they wanted in standard form. I see, they tricked me. They were having me so focused on the fact that it doesn't change it that I didn't realize it was not written in standard form. There we go. So you always want your real number in the front. That one was a trick question. All right, so let's take a look at this one. Again, we're going to be distributing a negative, which I'll do in red for negative if you guys ever dealt with power. All right, so in other words, this becomes 7 minus 8i minus 3i minus 6. So notice how they kind of separated the real numbers. They didn't make it all nice and easy for us. So real number wise, we're dealing with just 1. Sorry, I don't know why I put an I there. And then imaginary wise, with these yellow numbers that I have underlined, we're dealing with negative 11i. Sorry guys, I think the first day of break just has me really tired. Minus 11i. Okay, so we're gonna do that. Hit the OK button. So just remember, keep it in standard form. They might trick you. This one was tricky too, because I'm sure they were hoping that you would do 7 minus 3 because of the order. So just pay attention to the order and everything. That's one of the reasons why they created order. Like, I know it's annoying to always have to write it one way when they mean the same thing, but it's to make sure that mistakes don't happen. It's just easier to see the difference. All right. So let's take a look here. So the thing with I to the 5th is the same as I to the 1. Oh, and they show it as a little box. It's either I or it's this, and they keep going around in circles. So they're showing multiple situations of it. I like doing the little chart, but this is cool. Honestly, they should do a circle, but I guess they use a square, so it's easier to distinguish the side. All right. So now we want to simplify this. So like I said, the easiest way to do this is to do it the remainder by dividing by 4, because there's 4 sides on that square. Oh, that's another reason why they probably do it. It's like there's 4 sides on the square, so we divide by 4. So 4 goes into 14. Well, it doesn't really go into 14, but it does go into 12 3 times. Remainder. And we see here that 4 does go, if 4 goes into 12, 4 has to go into 24, because 24 is double 12. So it's going to go in there twice as much. So our answer has no remainder. There's no remainder here at all. So it's basically I to the 0. So if it's I to the 0, that just means it's a 1. Anything to 0 power is 1. Perfect. So let's go over here. And whatever the problems are, that'll be the end of this video. The rest will be in another video. Hopefully I'll be able to record it later today. Reduce this power I to the lowest possible degree. So again, we're going to divide by 4. 4 does go into 5 one time. I mean, again, it doesn't really because there's still a remainder. And 4 we said goes into 12, but this obviously isn't 12, so we're going to do 2. So that means we're going to have a remainder of 3. So when we write this down, we're going to write it as I to the power of 3. Perfect. I don't understand why it's not the power of 3. Use the keyboard, right? lowest possible term and simplify. I raised, that is a 51, right? That's 11, 2, 8, 3. Oh, reduce the power of I to the lowest possible degree and simplify. Does it literally just want me to write down 3? Okay. Let's see what they wanted the answer to be. Ah, they didn't just want I to the 3. They meant that's what it meant by simplify. They wanted it to be negative I. So I was right. It's just they wanted it in the form of either I, -1, negative I, or 1. So they always want one of those 4 answers when they're asking you to simplify. All right, let's take a look at this next one. Reduce the power and simplify. So I'm not going to be tricked again. I refused. So if we do 4, 4 goes in, doesn't really go into 26, but it does go into 24. And we said that was 6 times. So we don't really care about this top. We mainly care about the remainder. The remainder is 2. Well, we said I to the squared is square root of -1 times square root of -1. So that means our answer is simply -1. Oh my gosh, what do you want from me? Lowest power and simplify. I squared, that would be -1. The remainder is 2. Negative. No, yeah, that would be it. -1 times -1 is -2. I don't know what they. Yeah, okay. I don't know what you wanted there. I think if you guys, for you guys watching, I think what they wanted you to do is write that whole thing out, which to me doesn't make any sense because usually Edmentum just like, yeah, just put the answer in, we're fine. I guess just write all of this down. Well, you guys probably figured that out when you tried to do the other one and got it wrong. All right, let's take a look here. So another one. So let's see if I can get this one right. I'm gonna say we have to do I, and we're gonna do let's see here. What was it? Control up, and that's 45. And we're gonna set this equal to I control up 44, because 44 is a power of 4, times, let me use their times button so they don't get all picky here, times I control up to the power of 1, meaning that our answer here is simply just I. I have absolutely no idea how they want me to do this. So let me try this. 1 times I, which is equal to I. Get rid of this first part. I'm sorry, guys. I don't know how they want us to solve this. Oh, it looks like they want a times 4. That's um I'm sorry, guys. I really wish I could grade this, but you can see the answers here, hopefully, to help you out through this. Edmentum is just being really picky to the point where I don't know how they expected us to know that they wanted the times 4 there. 4 times 11 is obviously 44. I just assumed they would knew it, but I guess I was wrong. And I'll finish this part later. So we'll do slide 30 and I'll hopefully finish it off in the next video. All right, guys, I'll post this up right now.